My talk is titled "How PackageCloud I/O Works." It's a very short talk. I know everyone has been loaded up with a lot of information today, and it's the end of the day, and people want to party and get home and relax. No problem. It's a very short talk. It won't be long, I promise. Let's get started. Здравствуйте. Um, who am I? My name is Julio Capote at CapoteJ on Twitter. I work at packagecloud.io. It is the best package repository money can buy. Okay, so you may have heard one of my colleagues, Joe D'Amato, give a talk earlier today called "Infrastructure as Code Might Literally Be Impossible." It's a very good talk. The slides are up there. I suggest you check it out if you're into, computers and seeing how they don't work. Um, So we also written a very long 150-page networking blog post that covers every possible aspect of the Linux networking kernel stack. If you're really into networking and really want to optimize your network throughput, I highly recommend you check it out. It is also available at this link. Okay, so enough about that. Let's get on with the talk. So the structure of the talk will be, we're going to start with a high-level overview of package management, what it is, how it works. Then we're going to talk about the architecture that package.io uses to enable package management. And then we're going to go into some tips and tricks about scaling and monitoring our architecture. And we're going to talk about some failures and lessons learned along the way that happened to us. So we'll get started. So what is package management? So it allows you to install identical software on all of your computers. By identical, I mean byte for byte. A lot of people will use Chef or Puppet to compile software on all their computers. And the problem with that is that you can have different dependencies on all your different computers. And so you think you're installing Apache 2.0, but then you have Apache 2.0 linked against a different version of SSL. And there's a bug that only happens when requests hit a single machine, and then it becomes very difficult to debug. So packages let you have byte for byte software identically on all your computers. It's very important, but also very subtle. So this also lets you have reproducible builds. I know that I can check out our I know that I can check out our website at a specific commit SHA and spin it up, and then know that everything will be the way that it was built at that revision. This also lets you do easy upgrades and rollbacks. All you have to do is push a new version of the package up, run Chef on all your computers or Puppet or whatever. They pull it down. You have the new version on all your machines, and you know that that's the version that you're getting. It also lets you uninstall packages very cleanly. A lot of times when you compile software on all the machines that you run, it's possible that when you remove that software, you leave artifacts around, which cause very hard to debug bugs later on that are very hard to find. So when you use a package, you know that the installation and the uninstallation are going to be very clean. So then we're going to talk about what is the package repository. So package repository is a central place where all your packages live. Hopefully it's secure using HTTPS and GPG signing so that you know what you're getting is exactly what you want and not some Trojan package that's in the middle there. And it's also specific to the runtime that you're using. So Java has its own package manager, Ruby Gems has its own package manager, Python, so on and so on. So then, where does package.io come in? We are a package repositories as a service. So it's designed primarily for automation. So we have an API that lets you drive everything, and you can get everything you can do on the website, you can do via the API, and it's scriptable. We provide plugins for Jenkins, Chef, Puppet, all that stuff. So you can easily just drop it into your infrastructure, and it all just works together. You don't have to write a lot of scripts and stuff and custom things to do things that you want to do. It's all there. We support public and private repositories. So we have a token authentication system that you can generate as many read tokens as you want and hand those out. And then you know that the access is segmented to those read tokens. You don't have to just share the same credential with all your friends to make sure that they have their stuff. You can give them all a separate read token and then know how many times a particular read token has installed which version of what package. Very useful. It also works with our statistics API. You can pull down and see which customers or which clients have downloaded the most packages, so on and so forth. We also support multiple platforms in single repository. So in the same repository, you can host Java packages, Ruby packages, Python packages, Debian, RPM. So then, so one of the key things about our website and one of the differentiators of our competitors and also using open source tools to do it yourself is that we provide a very cohesive, rich experience, which we call the PackageSound Experience. So basically, you just upload your package via our API or a browser, and that's all you have to do. Just upload the package. We automatically parse all the metadata needed from these packages. You don't have to fill out any forms. You don't have to do anything. Just by uploading the package, we're able to read out the manifest or whatever metadata that's provided in that package and then create the package in the way that it can be installed natively by the package manager without you doing anything else. So we also, when we read this metadata in, we go and we update the indexes required by those package managers, and we sign it with a GPG key that's unique to every repository. So you know that everything is secure, signed, and working. And then now you can install this package from a CDN automatically. So just by uploading your package, you get all this for free. How does all this work? So I promise this isn't like a pure marketing talk. We're going to get into the meat of how this works. So first and foremost, we do a lot of research. So whenever we support a new package type, we have to spend weeks, maybe months, reading the source code of all the clients and package managers for that package type, and all the server code for it to make sure that if there's any bugs that the package manager has, we also have to support those bugs and the clients, and different versions of clients don't support everything. So we have to make sure we have to know what we're supporting, because we want to provide the most seamless experience possible. So you can just link your customers to your repository, and then no matter what version they're running of whatever clients, they can install the packages in the best way possible. And then in order to support the metadata parsing, so you don't have to fill out any forms at all, we have to write custom parsers for each of the package types that we support. So this involves looking deeply at the specifications for each of the packages that we support, so that we know that when you upload a package, we know how to find the information that we need to generate the indexes for the package manager to install. It also comes with writing these custom generators that know how to generate the specific indexes that each of the package managers need to install the software. And then we also have tons of monitoring around to make sure that all this stuff is happening the way it should happen all the time, so that every time you upload a package, you install it, it just works every time. So we have a pretty boring architecture. We use dedicated hardware. We run Nginx in the front. We use Ruby, Rails, Sinatra to actually run the code that provides all the reading of the packages and the serving of the metadata and stuff. And then we use MySQL to store all the information that we need from all the packages, all the dependency information, all the stuff, so we can draw an interface that is like usable for the user. And then we use S3 to host all the package objects. And then we use Amazon Key Management Service to host our GPG keys. So for every repository gets a GPG key on KMS. We don't ever see the private key. So there's no possible way that we could leak it or lose it or something. It's very secure. And then we use Rescue for our job tier. And then lastly, we use Fastly for our CDN to serve out all the packages, so that when you install a package worldwide, it's fast no matter where in the world you install it. This is a diagram of our architecture, pretty basic. You can notice that there's no one thing that we control. Everything has redundancy at every layer. It seems obvious, but this helps you make sure that whenever something does go down, you can easily fail over, or automatically there's other things that could handle those requests or jobs, so that the site just keeps running all the time. So now we're going to get to the tips and tricks part of things that we've done to help scale this product. So the biggest thing that we do is just let Nginx do as much work as possible. Nginx is an incredible piece of software. It's really fast. It doesn't have a lot of bugs. It just works every day really well. So we try to do as much as we can inside of Nginx. And then one thing that we also do is that we carefully look at everything with strace, like a microscope, to make sure that we don't have programs or libraries that we're using doing unnecessary work on all the computers that we run. I'm going to get more into that later. So it's very easy to think about going horizontally scaling first as opposed to vertical, just add more computers. But because we use dedicated hardware And because we're bootstrapped without any funding, we try as much as possible to scale vertically first before we have to introduce more servers. So this lets us want to get the most utilization possible per machine, which is not usually most people just care about just adding more and more machines because that also increases redundancies. For us, it's more about increasing the utilization per machine as much as possible. So here's some things we've done for that. So this is vertical scaling tips. So as I said, it's important because we're bootstrapped, so we want to make sure that we use as much of the machine as possible because we're paying for it all the time, no matter what. So one of the first things we do is we use a really cool feature that Nginx has called XSL redirect. So what this lets you do is it lets the app server send out a header that then Nginx will read and then stream to the client. So there are some situations that either the package manager doesn't support redirects, or for enterprise product, we let people use a local storage as an option. So instead of having an app server in Ruby sit there and stream bytes to the client very slowly, the Ruby server does the authentication and then just gives Nginx the location of where to stream, and then Nginx will handle the streaming to the client, and then that way the app server is not tied up doing that, and it could do something else that Nginx can't do. So that's a really good feature. I suggest you look it up. There's probably ways you could use it in your own infrastructure that will speed up a lot of things for you. In the same token, we also, package managers for a lot of the package types that we support generate a ton of requests that aren't really useful, stuff for like translations and like optional things that aren't really necessary for the installing of packages onto a server. So for things that we don't support, instead of 404ing them at the app server, we just 404 them at the Nginx level, and that way the request doesn't even make it to the app server. So that's a good trick. We save a lot of CPU and RAM this way. And then another thing is we switched to using TC-Malloc. They advertise a 20% reduction in overhead from regular Malloc, and we confirm this in our own graph. So definitely use TC-Malloc wherever you can. This lets us run a lot more app servers per machine. And then the Ruby GC defaults are still not very good. So you definitely want to go in there, first graph all the Ruby memory usage stuff, and then optimize the GC settings for your workload so that Ruby isn't constantly expanding its heap and stuff in times it should just be serving requests. So we've optimized our GC so that it's just serving as many requests as possible as opposed to doing any garbage collection. So in the spirit of this, one of the things we observed via strace is that we saw a ton of calls to constantly reading the local time on the computer and reading a file called etc local time. You just see tons of these read calls all the time. And then we looked into it, and then it turns out that just by setting an environment variable, you can save millions of system calls. Just by setting a TZ variable for their time zone, it avoids having to look up the local time on the computer, reading the local time zone file on the computer, and then you actually save a lot of CPU this way. And so there's a blog post about that there. It's a really popular blog post. It was really well written, not by me, written by my colleague. But and then if you don't believe that saving millions of system calls will actually give you any performance, we've written a follow-up blog post called Syscalls Matter. And in there, we talk about how we benchmark the micro-optimizations of system calls, and you can see how just by saving a few million system calls, it actually adds up at the end of the day to some very large savings. So, and then we don't use EC2, but you might, and you might find this blog post interesting where we talk about, because of the way that EC2 does virtualization, it cannot cache the result of a system call, and thus it uses the same system call all the time, and then this makes it 77% slower to get the time of day on an EC2 machine, which is, it turns out that programs do this a lot. So you should read this blog post if you use EC2. There's some tips in there on how you can prevent this and why it happens. And if you're interested in Linux and kernels and system calls, it's also very interesting just as a, as a informative blog post. And then, so monitoring plays a big part of our architecture because since we have a small team and everything is dedicated, you want to make sure that we know exactly what's going on all of our computers. So one of the first things we did was use syslog. Everything in the world speaks syslog. It's really easy to set up. I know it's tempting to use something like Graylog or Scribe, something more advanced or fancy. You don't need it. Syslog gets you very far. It's very performant. It's compatible with everything. Your operating system already uses it for its own logs. So you want to just use it to get that going, and it's really interesting the stuff you can see when you have syslog configured, all the information that it provides for you. So definitely use it. That's a good monitoring tip. And then we also, our logs do double duty. We use logs for our own human consumption. What went wrong? What happened at this time? And we also have tools automatically parsing our logs and using that for monitoring. One of the awesome things that we use for this is the CollectD, the CollectD software. It has a plugin called the tail module. This is probably one of my favorite pieces of monitoring software. You can give it a log file and a regular expression, and then based on occurrences in that file for that regular expression, it will graph metrics out to whatever backend you have configured for CollectD. So anything that emits a log that's somewhat parsable, you can just throw it into CollectD, and then you can get a ton of information out of it without having to have your app server report these metrics. You're already logging these files, so you might as well get performance out of them as well. So, and then you should also think about when you're writing your own custom logs to make them parsable. So don't just write like a format that looks good for you as a human. Try to come up with a format that you can write an easy regex against, that you would then be able to use that for monitoring. So one of the things that I've done is I created a simple plugin for Rails internally that just by dynamically saying log4 underscore whatever you want, this creates a log category on our logging server, and then it will just throw whatever string you want into that logging category. And then when it's this easy to log, you end up doing it everywhere, and your colleagues end up doing it everywhere. And then you end up having a ton of logs, and it's very easy to find what you want because everything is its own category, and it makes it really easy to go back and see what's going on at a particular moment in time. So similarly for metrics, I wrote a simple metrics wrapper around our metrics provider, which we use with Librado right now. This lets you wrap a block of code in this wrapper, give it a name, and then just by doing this, it automatically puts the benchmarking information for this function onto a graph somewhere, so you can very easily see how long something is taking and if there's any bottlenecks that are obvious. So just by doing these two things, very simple in our app code, you can then you can have a ton of data about how things are working in your system. So another important thing is to make sure that you get the aggregate metrics as well. So like average isn't really super useful in server programming because a lot of things don't fall on a bell curve. So using P50, P99, and counts, just how often is something happening, are way more illustrative than just getting the average of something. So, because usually you only see performance problems up in the P99 or P90 level. So different monitoring packages will provide different ways of getting this. You should research on how you can get P99 metrics going for your application. It's very, very important. So I'm going to talk about some failures that we've experienced and lessons that we learned from that. So a few years ago, I don't know if you remember, Simple DNS was getting DDoSed, and it took down a lot of websites with it, ours included. And this is something usually you don't think about. We certainly didn't think about. You just set up DNS, add your records, you're done. It works for years. You don't think about it until your DNS provider goes down. And then, so because of this, we actually looked into setting up a primary and secondary DNS. Turns out this is pretty easy to do if you research it and think about doing it. It uses a record type called zone transfer. This lets you just, whenever you add records to your primary, it automatically replicates them to a slave provider. So you want to also make sure that when you set up DNS this way, you want to make sure that they're different companies. A lot of DNS providers nowadays are actually subsidiaries of each other. So you want to make sure that you're actually getting completely two separate DNS providers because a lot of times they all go down at the same time. So just make sure they're completely different, and then you should be good there. Another lesson that we learned is dedicated hardware. So we initially got this because it was inexpensive for us. We happened to get a really good deal with our hosting provider. They were doing a deal for like startups. You got like a certain amount for free for the first year. So we went with it, and it ended up being okay. It worked really well for us for a while. We also get really excellent performance out of it. But then after a while, you start finding out the cons of this of this approach, where when things go wrong, they go really horribly wrong. Like RAM fails, it fails, and the machine goes completely dark. You have to use like a special protocol to access the machine. Hopefully, your hosting provider gives you access to that. Like I'm talking about IPMI. And then another thing too, it's easy to buy more than you need because the the resources are really as granular as they can be with it would be with virtualization. So it's easy to, you're seeing a lot of traffic pattern 1 week, you buy extra servers to accommodate for that, but it turns out that customer was just doing a big rollout that month and they're not doing that anymore, and now you have this extra server turned on, hanging out, it's not really doing anything. So yeah, it's really easy to over provision. That's one bad thing. And then also the maintenance windows are very long. So we had a stick of RAM go bad in a computer, and it took half a day to get it going because they replaced the RAM. But then it took them forever to find out how to run memtest, and then they had to run memtest, which takes a long time. So in another environment, we would just spin up another machine, it'd be fine, run Chef on it, start serving requests. But because we're dedicated, and we can't just bring up new machines all the time, we had reduced capacity for half a day until that thing got up and running. So I told you it was going to be a short talk. That's the end of the talk. If you have any questions, I'm happy to answer them. But до свидания. Go ahead.
As I understand, you provide commercial solution. In this presentation, I didn't see any comparison with other competitors on the market. Do you have any, or what benefits I can get using your software instead of I buy Amazon and Cloudflare, for example, together?
Mm-hmm. Yeah, so the question was, what are what makes PackageSound better than other providers and the alternatives? I didn't add anything like that here because I didn't want the talk to be too marketing focused. I wanted to deliver actual substance to the people attending. If you wanted to watch a commercial, I feel like that would have been disingenuous to people who attended this talk and this conference. We do provide free accounts, so we invite you to sign up and give it a try, and then you can make that decision for yourself. The website also provides a lot of the benefits for different package managers, but the main thing is that we are on top of all the bugs that are happening. So you could set something up yourself, but you're going to run into bugs running it securely on your HTTPS and GPG. It's very nuanced way to set this up. It's not very straightforward because it usually involves a lot of configuration on the client side and the server side that is not obvious off the bat. So, and then the main thing that we provide over other commercial players is that we do a lot of behind the scenes work to make sure that when you upload a package, it just works. A lot of other providers have a lot more upfront configuration that you need. So, but yeah, that's the answer. Basically, I didn't want to turn this into like a full marketing talk. So I really wanted to focus more on the architecture and the lessons learned for building this out. So. Mm-hmm. Yeah, it's this typical build. So the question was, what do we provide over Artifactory or like an open source Nexus or Kaiva and stuff like that? Is you have to set this up yourself. You have to monitor it yourself. You have to make sure that it stays up all the time. Sure, sure. I mean, that's okay for you. It's a lot of people, a lot of our customers don't want to worry about that kind of. Yeah, you don't have to. You don't have to. Yeah, yeah. Well, I mean, not everyone has the
What
time. Not everyone has the time or the desire to do all that stuff. Some
almost
people
all
just.
companies have DevOps or system administrators.
Yeah, sure, but you want to spend that time working on your own
You provide
problems,
a
or you want to
solution
add?
all in one. We pay, you provide our service for us.
Yeah.
I don't
Yeah, I
see
mean-
any benefits, any other benefits. I can't see any other benefits as we get working service after we paid for it.
I don't really get the question. So, what other benefits do you get? Is that?
I can set up your service you provide myself in
Yeah.
short term.
Sure. Why use any service? Why use a DNS provider? Why use S3? Why use you could set all that stuff up yourself simply, but it comes down to a build versus buy thing. A lot of people, a lot of smaller companies that don't have DevOps team, don't have administrators, or they have large teams, they don't want to
Small
invest.
companies don't have much money to buy.
Yeah,
such
and
service.
they have even less money to spend on spending hours configuring and learning about all the bugs and getting stuff working securely, backups, making sure how to get statistics going from all the packages that have been installed, getting stuff going privately. You have to share a token. You know, it sounds simple, but once you sit down and do it, I promise you that it's not.
Okay, thanks.
No problem.
You told you are using syslog for gathering logs,
Yes.
and then use collect D to pass metrics out from the logs.
Yes.
Do you send logs over network to some other host, or how do you? Parsing should give some performance impact, or how do you deal with this? With that?
Great question. So, so what we do is we actually have a server that we've dedicated just for logging, and actually every server runs syslog on it. So they first log locally, and then the local syslogs relay to the main logging server, and then we also run collectd locally. So when collectd is running, it's parsing the local versions of the logs. It's not running it on the central server. So that way you get redundancy. If the syslog server is down, we still have logs and we still have metrics. And for your second question about the impact of parsing, we haven't seen any. Collectd is really efficient, and so is syslog. We dump out a ton of logs, and we have not seen any significant impact from doing that. So it's been working well for us.
Okay, thank you.
No problem. Thank you.
Hi.
Hi.
I just wanted to say thank you for their service. We are using it for Toronto.
Oh, thank you.
hosting
Hi,
Toronto
guys. Yeah.
Packages.
Toronto, yeah.
Yeah, so it was great. Saved us a lot of time, a lot
Yeah,
of
thank you.
headache, and provided our community with actually timely delivery of builds for
Great.
many platforms. Thank you.
Yeah, thank you. Thank you for stressing our servers and helping us find out a lot of bottlenecks and making our servers more efficient. Thank you.